Okay, so today we're talking about natural logs and the exponential function, which is a special log and a special exponential. So we'll start off by talking about the exponential function. So that is the exponential function, y equals e to the power x. And e is just a number, it's a constant. E is 2.71 and a load of other stuff goes on forever. We can round it to 2.71. Normally we're just going to use it as e, so on your calculator you've got an e button. I put rough because approximate, because you don't have all the extra decimal places. What e looks like, you might have seen before, is that so it's an exponential curve going through one with an asymptote at y equals 0. And e is a special function, so it's the only function that is its own gradient. So that's going to make more sense when we do calculus and look at differentiation. But the gradient at any point on this curve is equal to e to the x. So function is its own gradient. We'll be talking about that a lot more when we move on to gradient functions and differentiation. Now e to the x has an inverse. So just as we got multiply, divide, add, subtract, we also have an inverse to e to the x. And the inverse of e to the x is log or ln of x. So ln is the natural log, it comes from the French logarithm naturel, which is why it's ln and not nl. And natural log is basically log to the base e of x. And because we use log to the base e of x so much, we give it its own symbol, give it its own name, which is ln of x. Ln of x if you like, but log naturel, ln normally of x is that. So ln of x undoes e of x and e of x undoes log of x. We can sketch ln of x. And ln of x is basically the reflection of e of x in the line y equals x. So if I put reflection line there, so we go, e of x, reflection line, ln of x. So they are inverse of each other, we'll talk more about that next year. Asymptotes, there we go. So e of x undoes log or ln of x. Okay, so for e of x or log of x equations to solve, so we'll go through these, show you guys how to do them, and there's going to be some similar questions on the video. Okay, so the first one, we've got e of x equals 5. We want to get x on its own. So to undo e of x, we're going to log each side, ln both sides, or ln both sides. So ln of e to the x equals ln of 5. And there's two ways you can think about this. You can think about either the x comes down the front because of the power rule, or you can think the ln cancels out the e. I prefer to bring the x down the front. So we're going to use power rule. X jumps down here. Because of the inverses, they cancel each other out, so you get x equals log 5. Alternatively, you could just say ln to cancel that e, and we just get x, but sometimes students get stuck with an x just floating around. So ln e cancel, leaves us with x equals log 5. Okay, next one's going to be similar, but the opposite. So we're going to subtract 1 first. Divide by 2. Then to undo a log, we're going to e both sides. E and the log cancels, we get x equals e squared. Remember, e is just 2.7. So we can type either of these into our calculator and get the final answer. Okay, next one we've got a quadratic. So hopefully you can spot quadratic form, something squared, something to the power 1, something to the power x, 12. So if I write this out again, it says e to the x squared minus 8 e to the x plus 12 is 0. We can either try and factorize this, or we can make a substitution. So we could say y is e to the x, so we get y squared minus 8y plus 12 is 0, and then factorize this. factorise it, you get y equals 2 or y equals 6. Remember, y was e to the x. So e to the x is 2, or e to the x is 6. And then we're back to when we started up here. So we're going to log both sides to get x ln 2 and x is ln 6. Log both sides, cancel the e, x is ln 6, x is ln 2. Okay, the next one is slightly more difficult. So we're going to have to log this and then use some different log rules. So because ln is still a log, all log rules apply to ln as well. So I've logged both sides. Now we're going to use the multiplication rule to split this up. So ln of 4 to the x plus ln e to the 5x plus 1 and 5. Now we can use the power rule to bring this down. And ln and e are going to cancel to give us that. So use power rule and then cancel log and e to get this. Now we just want to collect the x's. We've got two x terms here, so we're going to factorise those. So taking x out as a common factor, added the 1 over at the same time, we get this. So I'm just going to divide by this to get x. And we can type that into a calculator as well and solve it. Yeah. Cool. Right, that's it for logs and e's. So real trick is just using them to solve equations. Exponential rules apply to e, and log rules apply to ln. And just make sure you're using them to undo each other, not making up any weird new rules.